Hey everyone, Mr. Fransky here. Today we're going to be talking about integration by parts when things end up going cyclic. It can be a little bit annoying, but it's not terrible, so hopefully we can get through this together. So students will be able to solve indefinite integrals that are cyclic when integration by parts is used. Let's see if we can find a little less offensive color. All right. So, key vocabulary, indefinite integral, that's what we've been talking about lots in this chapter. Antiderivative, integration by parts, and the cyclic method. So nothing too surprising there. So integration by parts, integral u dv equals uv minus integral v du. So we talked about in the last video, I did lots of example problems about logs, inverse trig, and polynomials. So the question is, what if you are forced down to the bottom here, where you have only exponentials and trig as options? So first I just kind of want to go through kind of how it works just in terms of variables. So back in algebra, you were probably told to solve equations like this for a certain variable. So if I wanted to solve this for a, so get a by itself, I think we want to get all the a's on one side and everything else on the other side. So I would add 5a to both sides, add 5a here, add 5a here, and then I would have 6a is equal to 12b plus c, and then to solve for a, I would divide both sides by 6. Right, so I would have a is equal to 12b plus c over 6, or you could write it as 1/6 times 12b plus c. So, same idea applies here. So if I want to solve for this integral, if this is my goal, and I have it on the left, and I have it on the right, what I'm actually going to encourage you guys to do is set this to a variable. So say, let a equal this thing. Okay, so then I have a equals 12b plus c minus 5a. And so then to solve for a, I would add the 5a to each side. So I have 5a here and 5a here. These cancel, so I have 6a equal to 12b plus c. And then to solve, I divide by a, right? Or divide by 6, excuse me. So I have a is equal to 1/6 times 12b plus c. And then you could actually rewrite it, right? So this is integral log base 2 of x dx is equal to 1/6 times 12b plus c. So this is just an example I made up. The integral we don't actually have to solve for. But the key is, if you see it on both sides, you can just bring it all to one side and then just solve, right? Because all you want to do is get rid of the integrals on the right side. So let's try this with an example and see what happens. So we have integral e to the 2x sine x dx. So integral e to the 2x sine x dx, what I'm going to do here is I'm going to choose my u. So based on our lipet, L-I-P-E-T, we're going to choose an exponential. And I'm going to tell you right now, it's about 6 of one, half dozen the other if you choose the sine or the e. I always choose the e just because that's how I do it. If you want to try it with the sine and see if you get the same thing, you can. But let's do it here. So we have eu equals e to the 2x. That means du is going to be 2e to the 2x. And our dv then is going to be sine x dx, which means our v is going to be negative cosine x. The antiderivative, take the derivative of cosine, you get negative signs, we need that negative out there to cancel it out. So let's put together our u substitution, if I could get through it without moving the thing. Okay, so uv is going to be negative e to the 2x cosine x minus the integral of v du, So negative cosine x times e to the 2x. So negative 2 e to the 2x cosine x. v du, there we go. And that's dx. So what I'm going to do now is that this is equal to this, right? That is what integration by parts tells us, that these are equal. So let's call this a. And I'm going to set a is equal to this, right? uv minus integral v du. So my goal is to look for a the entire time. I'm looking for this thing to show up again. Right now it hasn't, right? I have a cosine over here, but I don't have a sine. So I'm going to rewrite this a little bit prettier. So a is equal to negative e to the 2x cosine x. Two negatives here, so I'm going to do a plus 2 integral e to the 2x cosine x dx. Now what you notice is we have another integral here that's hard to solve. In fact, it looks almost identical to the original one, but it's not the same. So what I'm going to do now is I'm going to do integration by parts on this part. So I'm going to do u equals e to the 2x again. Then du is 2e to the 2x. dv is cosine x dx. This is a little bit different than last time. So then v is just sine x, right? Because the antiderivative of cosine is sine. Okay, so now I have a is equal to negative e to the 2x cosine x plus 2 times, I'm going to do integration by parts on the inside here. So I'm going to have uv, which is e to the 2x sine x, minus integral of v du. So v du is going to be 2e to the 2x sine x. Okay. Now, where people usually get messed up with this is they don't do a correct job of distributing and making sure the negative signs are accurate. So let's see what we have here. I'm going to distribute in the 2, and I'm also going to pull this 2 out because I'm looking for a, and it looks like we're almost there. We have e to the 2x sine x there. So right now I have a is equal to negative e to the 2x cosine x plus 2e to the 2x sine x. Now it's going to be minus 2 times 2, so I have minus 4 integral e to the 2x sine x dx. I missed a dx up there. Okay, well, what is this? I have integral e to the 2x sine x dx. That is a. So I'm going to write this. I'm going to write a is equal to negative e to the 2x cosine x plus 2e to the 2x sine x minus 4a. All right. So now I can just add 4a to both sides. Right? So I'm going to add 4a to both sides. So I have plus 4a plus 4a. Oh, goodness. Plus 4a. Oh, don't do that to me. There we go. Okay. So if I add 4a to both sides, nope. There we go. So I have 5a. Over here. So I have 5a is equal to negative e to the 2x cosine x plus 2e to the 2x sine x. And now how do I solve for a? I just divide by 5. So I have a is equal to 1/5 times this whole mess. Negative e to the 2x cosine x plus 2e to the 2x sine x. Now you may be out there just yelling at your screen. You don't have a plus c, Mr. Fransky. You're right. Because when you do this, the integral, like we never evaluated this integral, right? So we never really had an opportunity to put a plus c in here. So what you do is at the end, you just do plus c. So I'm going to write it now. So this whole thing, right, a is the integral e to the 2x sine x dx is equal to 1/5 times negative e to the 2x cosine x plus 2e to the 2x sine x. And then at the very end, I'll put a plus c. So, cyclic method. Kind of weird, right? We did integration by parts twice so that the same integral popped up again. I assigned it to a variable, and then I just added it to both sides so I could solve for the variable, and then we had a plus c at the end. So make sure you don't forget that plus c. It's a very typical mistake to forget the plus c on these problems because you never really evaluated this integral. We just kind of cheated. It almost feels like cheating, but it's fine, right? This is just like solving for any other variable. Not a problem. All right, let's try another one. So this time, I don't know why that came along. Well, let's just get rid of it. No, it's going to stay there. Okay. Well, let's try it with it there. So we've got e to the x cosine 3x. So this time the cosine 3x is the part that has the number. That's kind of what I wanted to do. So we're going to make u. Oh, there it went away. Of course. E to the x. And we're going to make, so du is just e to the x dx. That's nice and simple. So then dv is going to be cosine of 3x dx. So then v, remember, don't get confused with taking derivatives versus integrals here. So I'm anti-deriving both sides. So dv, or v in this case, is going to be the antiderivative of cosine 3x. That's going to be something to do with sine of 3x. And think, if you took the derivative of this, the 3 would come to the front. So I need a 1/3 out there to cancel out the 3. So now we put it together. So I'm going to call this a again. You can call it whatever letter you want, right? So a is equal to uv, so it's 1/3 e to the x sine 3x, minus the integral of v du. That's 1/3 e to the x sine 3x dx. So we got our integral v du there. So now, let's see if we can pull out a 1/3 there. So a is 1/3 e to the x sine of 3x minus 1/3 integral e to the x sine of 3x dx. So we do u sub again. So u is going to be e to the x. Du then is e to the x dx. dv means is then a sine of 3x dx. So then v is going to be, let's see, negative 1/3 cosine of 3x. Okay, so integration by parts on that part. So we have a is equal to 1/3 e to the x sine 3x minus 1/3 parentheses, especially since we have a negative this time, Looks like it's going to be uv, so we have negative 1/3 e to the x cosine 3x. Okay, so that's uv minus the integral of v du. That's negative 1/3 cosine x. So v, so du times e to the x dx. All right. So a equal to 1/3 e to the x sine of 3x minus 1/3, sorry, let's distribute that out. So we'll have plus 1/9 e to the x cosine 3x. And then it looks like we'll have, so these two negatives are going to turn into a positive. So we'll have minus 1/9 integral e to the x cosine of, oh, did I drop a 3? There should be a 3x in here. Not bad. Okay, so e to the x cosine of 3x dx. So that is a, right? So right now I have a equal to 1/3 e to the x sine of 3x plus 1/9 e to the x cosine 3x, and then minus 1/9 a. So we're going to add a 1/9 of a to each side. I have 9/9 a over here. I'm adding one more, so I have 10/9 a equal to 1/3 e to the x sine of 3x plus 1/9 e to the x cosine 3x. And now we just multiply both sides by 9/10. So a is, I'm going to leave it on the outside because I don't want to deal with that. 9/10 times 1/3 e to the x sine 3x plus 1/9 e to the x cosine 3x. And then what do we need at the end? Of course, a plus c. There we go. Okay, so you can see cyclic method really not challenging. You just have to make sure that you're very careful about where you put your parentheses. The negative comes in, right? It distributes to everybody. And then we're just searching for that same integral to pop up again. And I'm calling it a. You can call it whatever letter you want, or you can just leave it as the integral. Okay? But the point is, we have to make sure at the end we end up just with all of the a's on one side. There are no integrals in our final answer. And we just kind of multiply by the reciprocal to be able to solve for it at the end. And I believe that's all I have. Love you guys. That's why I'm here. Have a great day.